In this video we have another trigonometric integral to evaluate. Not too bad. You want to pause the video and try it? Go ahead. I'll be right back. It should be clear by now that when you're working with trig integrals, besides knowing your derivative formulas, you also need to know quite a few of your trig identities. So the one we're going to be using here in this video is this one here, 1 plus cotangent squared x is equal to cosecant squared of x. And of course we need to know that the derivative of cosecant is minus cosecant cotangent of whatever angle you're dealing with. And if it's in terms of u, of course you multiply by the derivative of u with respect to x. Derivative cotangent of x is equal to minus cosecant squared of x. So in this case, what we want to do to start off with, we have this expression here squared. So let's go ahead and square it and see what we get. So it's to square the first one. We have a binomial type expression, two terms. So we square the first term. We get cosecant squared of 2x. And we have minus twice the product of these two terms, cosecant and cotangent. This will be 2 cosecant of 2x times the cotangent of 2x. Plus the second term squared, so they'll give us a plus cotangent squared of 2x. And this is dx here. So let's go term by term and try to integrate this. We know that the derivative of cotangent is minus cosecant. We know that the derivative of cosecant of an angle is minus cosecant cotangent. So we can integrate this one fairly easy. This one we can integrate. And this one here we can write that as cosecant squared of 2x minus 1, using the identity that we just went over at the beginning of the video. In other words, 1 plus cotangent squared of an angle is equal to cosecant squared of the angle. So solving for cotangent, this is what we get here. So let's just go term by term then. The integral of cosecant squared of 2x then is going to be a minus cotangent squared of 2x, and that's going to be over 2. I'm going to make it a 1/2 here, but I just put it over 2. As the derivative of 2x is 2, so do the opposite of what we do with derivatives, divide it instead of multiplying it. And for this one here, we got a minus cosecant of 2x, cotangent of 2x, so the antiderivative of that is cosecant of 2x. Again, the derivative of cosecant is minus the cosecant of the angle times cotangent of the angle. In this case, the angle is 2x. This will be a plus here. And then we divide by derivative of 2x is 2. So these would cancel here. And then you can check your answer here. Derivative of cosecant is minus cosecant cotangent of the angle 2x times the derivative of the argument here. You get that there. And then for this one, we're going to work with this then. We're replacing cotangent squared of 2x by this. So let's look at first cosecant squared. The integral of that is cotangent of 2x, and then you have a minus there. And then the derivative of 2x is 2, so that's divided by 2. And you can check it here. The derivative of cotangent of 2x is minus cosecant, but you have the negative here, so you get the positive there. And this times the derivative of 2x, which is 2, you put it out in front, we get that. And then the antiderivative of minus 1 with respect to x is minus x. And then it's plus the constant of integration. So then we just do some simplification here. So here we have a minus 1/2 cotangent squared and a minus 1/2 cotangent. Sorry, this is just a cotangent there. So it's minus cotangent of 2x over 2 and a minus cotangent of 2x over 2. We add those up. Minus 1/2 and minus 1/2 is a minus 1, so this will give us a minus cotangent 2x. Okay, so we're combining those two. And then this, I've reduced it down then. This gives me then plus cosecant of 2x. And we have the minus x. And then it's plus the constant of integration. So this is your final answer then. Minus cotangent of 2x plus cosecant of 2x minus x plus the constant of integration. Thanks for watching. We'll see you next time.